Alright, so this is going to be a quick lesson on the types of quadrilaterals and sort of categorizing them into different groups so that we can analyze them for their areas later. But let's just get into just knowing what the types are. So how this diagram basically works is, if you start at any shape and, let's say you start at a parallelogram, all the shapes that you can travel to from the parallelogram. Let's start at a rhombus. Right? You're starting at the rhombus, and all of the shapes that you can travel to following this arrow it belongs to that. For example, you can go from rhombus to parallelogram. That means, right? So you start at rhombus, you can follow this arrow to parallelogram. That means a rhombus is a type of parallelogram. Similarly, you can also follow it up to kite. That means a rhombus is a type of kite. You can also follow this arrow and then go up again to trapezium. That means a rhombus is a type of trapezium. It doesn't have to be one arrow. As long as there's a path, it belongs to that. That's how this diagram works. So that means a rhombus is not a type of square because this arrow only goes from square to rhombus, not from rhombus to square. So the direction of the arrow also matters. So this is a helpful guide. So if I asked you, is a rectangle a type of kite? What would your answer be? Well, let's try to find a path. Rectangle, parallelogram, and then trapezium, quadrilateral. You don't really have a path to kite. So no, a rectangle is not a type of kite. Okay, and then next thing we want to talk about here is that now that we know how this diagram sort of works, let's just work our way for each of these shapes individually and go talk about them a little bit so that we understand them before we go into the area problems that relate to them. So let's start with the most general one here. Actually, let's go even further. What's more general than a quadrilateral, which is the most general shape on here? Well, that would be a polygon. A polygon, right? Polygon. It's an n-sided shape, right? So that means it has any number of sides. It could be 3, 4, 5, 6, 7, 8, anything. As long as it's a closed shape, it's a polygon. So that's a polygon. So it's got any number of sides except 1 and 2, because you can't have a closed shape with just 1 or 2 sides. But the important thing is that a quadrilateral is a type of polygon. So if you had an arrow, you could go like this, right? Because polygon has any number of sides. Quadrilateral has a restriction that only there's 4 sides. So, right? So that's a quadrilateral is a type of polygon in that the restriction is that it's got 4 sides. And every shape below this has 4 sides because it's a quadrilateral. But there's some extra restriction on it on top of that. It's not just 4 sides. So let's talk about our first special type of quadrilateral, and it's the trapezium, right? The trapezium. So it still has 4 sides. Remember, every single shape, there's a path from trapezium to quadrilateral. That means trapezium is a type of quadrilateral. So it's still got 4 sides. But on top of that, there's another rule. And the second restriction is that the trapezium has 1 pair of parallel sides. And notice how these 2 sides, which are the parallel sides, are opposite. Why are they opposite? Well, they have to be opposite because parallel lines, right? What's their definition? They never intersect. That means if they never intersect, they obviously can't be adjacent sides because adjacent sides always intersect. That means the opposite sides have to be the ones that are parallel. That means the 1 pair of parallel sides are the opposites. That's a condition for trapeziums. So it's not saying only 1 pair of parallel sides is opposite, but if there's 1 pair of parallel sides, it is a trapezium. So we'll see if later on down the line, some shapes with 2 pairs of parallel sides, which you can see here, parallelogram, that's what it is. But a parallelogram is still a type of trapezium. So it is at least one pair of parallel sides, it's a trapezium. Second shape. Second shape is a kite. And the kite has a special rule that there's two pairs of adjacent sides. So two pairs of equal adjacent sides. So if you look here at this diagram, these two are equal, that's one pair, and this second pair, they both have equal length, right? And as a consequence of this two pairs of adjacent sides, there's also one pair of equal angles. So notice how the definition doesn't have the equal angles. The equal angles comes because of this two pairs of equal sides. It can't exist. If there's two pairs of equal sides, the opposite angles have to be equal, like this, like these two here. Right? So that's just a consequence. It's not part of the definition. It's just like when you learn about triangles, right? What's the definition of hypotenuse? What's the side opposite the right angle, right? Hypotenuse is the side opposite the right angle. But because it's the side opposite the right angle, it becomes the longest side as well. It's not by definition the longest side. The definition is just the side opposite the hypotenuse. But then a result of that is that it's the longest side. So that's kind of similar to that. Now we know trapezium and kind. Let's go to the next shape, which is the parallelogram. The parallelogram has the extra condition that it has two pairs of parallel sides, right? And again, they have to be opposite because they can't intersect, right? So it's the same, at least it's got the similar restriction to trapezium, but a little bit stronger, right? It's more, just one is not enough. You need two pairs of parallel sides, right? So two pairs of parallel sides. And that means there's another logical consequences from this as well. What that means is opposite side angles are equal because of the two pairs of opposite parallel sides. Opposite angles are equal. Actually, something I forgot to mention for the trapezium before as well. There's a consequence of this as well. This angle, let's call it A. This angle, let's call it B. These two are supplementary because remember, these are co-interior angles. These are parallel lines, right? And same with these two. This is not the definition of trapezium, but these are consequences of it being of having a pair of parallel sides, right? So the consequence is that A plus B is 180, and C plus D is also 180. Okay, well, now let's go even more special. Let's go to the rectangle. A rectangle is just a parallelogram, right? So it's still got two pairs of parallel sides. Always remember these two sides. These two sides are parallel, and these two sides are also parallel. But it's got the extra condition that all angles are right angles, right? And because of this, there's not much intuitive, like nothing special. You see just no extra properties, no consequences right away just by looking at it. But this definitely is a really nice shape and has a very easy formula to calculate area because of this extra condition. Now we go to rhombus. Rhombus is the same condition as a parallelogram, so it's still got two pairs of parallel sides, but on top of that, all sides are equal, right? So they're the same length, right? So these four sides are all the same length. And yeah, that's the rhombus. It's kind of similar to a parallelogram other than that. And then the most special quadrilateral of them all is the square. And why is this the most special? Well, look at this. It's got the property of all right angles from the rectangle, and also that all sides are equal from the rhombus. So a square has all right angles, all sides being equal, and then all the other properties of every single shape above it. That's the most special quadrilateral that we're going to study. And the thing is, the more, I guess, special, right? I'm using, obviously there's no video here, but I'm doing air quotes, right? I'm just saying special because there's more conditions on it, the more rules, or stricter rules. The more strict the rule is, or the more special the shape is, the easier it is to deal with, right? We've dealt with squares and rectangles all our life, and they're really easy to deal with. The more general it is, the harder it is to deal with mathematically. So we're gonna spend a little bit more time learning what the area formula for trapezium, for a kite, and a parallelogram, etc. Right? Because we're probably a little bit less familiar with those. But yeah, those are the types of quadrilaterals. And this is some visuals to show you sort of how the class of quadrilaterals is. So, I went online to find these visuals. A lot of these visuals are wrong. Like 90% of the ones I saw looked like this. And these are just wrong. The issue with this is that they put trapeziums, this is the American word for trapeziums, trapezoids. That's what Americans say. I don't know why. But Americans seem to they just do their own thing. But the issue with this is that they separate trapeziums from parallelograms. But we know from this diagram that parallelograms belong to trapeziums. So all the parallelograms should be inside the trapezium circle. And they're completely separate here. So that's not what we want. That's why it's wrong. So this is a better diagram. And this tells you the relationship between all of this. So for example, squares inside the circle for the rectangle. Right? We see that here. And then that whole red circle for the rectangle. Oops. Yeah, okay. Never mind, it's not showing up. Alright. This circle for the rectangle. Oh wait, why is the text going under? Things drawing underneath. That's weird. Let me just try to edit again. Maybe it'll drop behind. Okay, I can draw on it. Fine. Okay, that's better. Alright, so let's get rid of this stuff. So, what I was saying was that a square, for example, is inside this rectangle. That means all squares are rectangles. Similarly, rectangles is in this big square for parallelograms. That means all rectangles are parallelograms. And parallelograms are inside the one for trapeziums. That means all trapeziums are also parallelograms. And then I guess the ones that are not completely inside another shape is the kite. The kite is separate from the trapezium, except there's some shapes that are belong to rhombus, like the rhombus and the square belong to kite, but that's also inside the trapezium. So the intersection between the kite and the trapezium rule is the squares and the rhombus. So I guess that's kind of special. That depends. So anyway, these are the rules and the groups of quadrilaterals, and we'll deal with doing the areas of these shapes later, but hopefully they set you up to understand how these quadrilaterals interact together.